Record to find the length x if O is the center of the circle. Label point E and G. Join line BG. Since angle E equals 90 degrees and angle O equals 180 degrees, it is because the angle at center is twice that at the circumference of the circle. It implies that line BG equals the diameter of the circle. Thus, BG equals 2 times R, which equals to 12. Consider triangle BEG and use Pythagoras theorem for the square of line B. E equals the square of line B, G minus the square of line EG. Substitute values and we have that the square of line B, E equals 144 minus the square of x. Find the square root of the equation. It means that line B, E equals the square root of 144 minus the square of x. Consider triangle ECG and use Pythagoras theorem. We obtained an equation in x for the square of line C, G as shown on the screen. Find the square root of the equation and we have that the length of line C, G equals the square root of the sum of 5 plus the square root of 144 minus the square of x and the square of x as shown on the screen. It signifies that line D, G equals the difference in length between line C, G and line C, D, which equals the equation in x as shown on the screen. By Secant theorem, the product of line C, B and line C, E equals the product of line C, D and line C, G. Thus, substitute values and we have that the product of 5 and the sum of 5 and the square root of 144 minus the square of x equals the square root of the sum of the product of 4 and the sum of 5 and the square root of 144 minus the square of x and the square of x. Square the equation as shown on the screen. This implies that the product of 25 and the square of the sum of 5 and the square root of 144 minus the square of x equals the product of 16 and the sum of 5, the square root of 144 minus the square of x and the square of x. Expand the brackets. We obtained an equation in x as shown on the screen. Combine like terms, simplify and then rearrange the terms so that the product of 25 and the square of x minus 1521 equals the product of 90 and the square root of 144 minus the square of x. Thus, square the equation. open brackets and multiply out terms so that the product of 625 and the x to the power of 4 minus 76,050 times the square of x plus 231, 3441 equals 116, 6400 minus 8,100 times the square of x. We now rearrange terms of the equation to have a quartic equation in x as shown on the screen. Let y equals the square of x. Thus, substitute in our equation as shown on the screen to obtain a quadratic equation in y. Solve for y using quadratic equation general formula you have already known. And simplify. We have that y equals 1359 plus or minus the product of 216 and the square root of 15 all divided by 25. Then recall that y equals the square of x. Back substitute the square of x in place of y as shown on the screen. Take the square root of the equation and we have that x equals plus or minus the square root of the sum of 1359 and the product of 216 and the square root of 15 all divided by 5. Ignore the negative result as length cannot have a negative value. It implies that x equals the square root of the sum of 1359 and the product of 216 and the square root of 15 all divided by 5. Also, we have another value of the square of x as shown on the screen. Take the square root of the equation and we have that x equals plus or minus the square root of the difference between 1359 and the product of 216 and the square root of 15 all divided by 5. In this case, ignore the negative result as length cannot have a negative value. It implies that x equals the square root of the positive difference between 1359 and the product of 216 and the square root of 15 all divided by 5. Therefore, x equals the square root of the sum of 1359 and the product of 216 and the square root of 15 all divided by 5 or 9.3714 units to 4 decimal places. Also, x equals the square root of the positive difference between 1359 and the product of 216 and the square root of 15 all divided by 5 or 4.5714 units to 4 decimal places. Any of these two values satisfied the required value of x.